So we're gonna try to do the combustion analysis problem number 1. So as always, you want to read the question to see what is given. We are giving oxygen, carbon dioxide, and water. So unlike the usual question where we're giving the sample mass, we're now giving the mass of oxygen. What you needed to know is it is fully combust. That means we use all of the hydrocarbon, and this is how much oxygen it's gonna take. As always, the yield meaning arrows, and then these are my products. So let's try to write the equation. That's gonna look like this: CXHY, X and Y because we don't know. And I want to say O, and I want to say question, because we don't know if there's any oxygen in this hydrocarbon, plus O2 arrows, and it's going to give me CO2 plus H2O, right? So now what we're going to do is we're going to try to figure out carbon dioxide and water to find how many carbon and hydrogen each is. So we're going to use a carbon dioxide number, 23.118 grams of CO2. Okay, the usual, you can do this or you can do the multiplication. This is gonna be carbon molar mass plus the oxygen molar mass. There's two of them, gram of CO2, 1 mole of CO2. Okay, in 1 mole of CO2, you only have 1 mole of carbon. Leave this alone. We're gonna try to write the answer, but before we get there, we're also gonna set another things up here to convert that mole back into the gram. So 1 mole of C is 12.01 gram of carbon. So we're gonna get another answer called grams of carbon. So we want both this answer and this answer. Right? We'll be looking for these two answers. So we'll be looking for this one, the mole of C and mole of carbon. We'll be using both of them later. Okay, we're gonna do the same thing with the hydrogen, and then we're gonna do the same thing with the hydrogen setup. So this is gonna to be 4.729 gram of H2O is what's given in a question here. All right, I'm gonna move up, and then hydrogen mass 1.008 times 2 plus 16 gram H2O. That's gonna be 1 mole H2O. So unlike the carbon dioxide in water, in 1 mole of H2O, you will have 2 mole of H. Okay, again, that's gonna be one of our answer, mole of H, but then we're gonna continue on and say 1 mole of H would have 1.008 mole of, gram of H. Okay, that will give me gram of hydrogen. So we're gonna go ahead and compute this, and then I'm gonna go ahead and do that. I did that earlier, so I have a number, so that's gonna be 0.525. This is gonna to be 6.309. This is gonna to be 0.5250. This is gonna to be 0.529. I cannot round about like 3 decimal place about. Okay, so now next part what's gonna happen is you're gonna go back to our question and we say, wait a minute, they didn't give us this mass, but they do give us this mass, and this mass. Okay, so we know this is 18.214 gram, this is 23.118 gram, this is 4.729 gram. Okay, what you can do is you can add these two up. Okay, so I'm going to go ahead and quit add it up, 23.118, 4.729. If you do that, you're going to get an answer of 27.847. So that is 27.847 gram. Okay, that is how much product I have. So guess what this means? That means this side, right, the one that we don't know, the sample, plus the oxygen should also be 27.847 gram. Okay, now you might say, why the mass of reactant equal to the mass of product? This is called law of conservation of matter. Okay, so product, reactant should be the same. So all I'm going to do is I'm going to subtract this so that I can find that number. All right, so 18.214. So I did 27.847 minus 18.214. I will get 9.633 grams of this. So now I'm going to use this to find if there is any oxygen. So let's see. If there's oxygen, we should be able to figure it out. And I think there is some. So mass of oxygen. So equal mass of the reactant, our hydrocarbon, 9.633 minus mass of our carbon and hydrogen together, 6.309 minus, plus 0.529, okay? So I'm going to do that. So I'm going to get this at 2.795 gram. Okay, so we do have some oxygen. Again, we can't deal with gram here, so we're going to go to mole. So gram of O, so we're going to do mole of O. So 16 grams of oxygen is 1 mole of O. We're using regular O because we're doing mole ratio later with just each element. Okay, these are not diatomic yet because we're looking from here. So we're taking them as individual. Okay, so let's do dividing by 16. So we're gonna get 0.1747. That's gonna be mole of O. Now that we have mole here, right up here and here, we're gonna use all the mole together. So that is our CHO ratio. Okay. Notice that in class 1 we have the nitrogen, so we do have another one, but here we just have CHO. So we're gonna pick up the number. Make sure you put it the right one. So carbon is 0.525 mole. Notice that these are all mole, and then this is 0.525 also, and then this is 0.1747. Okay, based on this, oxygen has the lowest. Okay, so that would be 1 ratio of 1, and then let's see, 0.525, 0.747, that is 3. You get 3.005, so that's about 3. Now that we have this thing, now we can write it down our formula, C3H3O. Okay, this is our answer. Now the question didn't ask for it, but let's just say we're trying to practice writing the formula with them. Okay, the combustion formula. And let's say this is the real molecular formula, not the empirical formula. Okay, we don't know if it's empirical, but we're assuming that. Let's just try to write the equation for this one. Let's see what would we do. We're practicing. Okay, this is not part of the question. Okay, but we're practicing. So let's see what's gonna happen. Let's see if we can balance them. Again, you can always try to balance things to see if you can. So let me see if it works. 3 carbons, so I'm going to put 3 there. 3 hydrogen, okay, that doesn't work, so that's going to be 2 here to make it 6, so I'm going to put 3 there. Now, I can tell you already ahead that's going to be troublesome later, but hold on, we will see if it happens later. Just make sure you go back and change the carbon because this is now 6, this is not 3. Okay, so let's check now. Check for oxygen. Okay, right here, how many? 12. Right here, you have 3. 12 plus 3, you have 15 oxygen. Okay, let's see what's happening here. This guy has 2. This side has 2. Now this guy cannot be changed, so that means this guy better be 15 minus 2, which is 13, and we can't have 13 because it's every 2. So what you can do is you can do 13 over 2. But remember, we can't write over 2. So this whole thing got multiplied by 2. Okay? So what's the new formula look like? It's going to be 4 C3H3O plus 13 O2 go to 6 CO2. Oh wait, not 6. Remember, it's times by 2. 12 CO2 plus 6 H2O. And when you're done, you can always double check. This is what I like to do. I always double check. Carbons, 12 carbons. Okay, right here, 12 carbons. Hydrogen, 12 hydrogen. Okay, right here, 12 hydrogen. Okay, oxygen, 4 here, plus 26. Okay, so that is going to be 30 oxygen. Let's see. 24 plus 6, that's also 30 oxygen. So you can see my number match. Okay, that's called balancing. So your left side has to be equal to the right side. Why? Because of the law of conservation of matter. Okay, so but for question 1, if we're looking for the answer, that would be our answer, C3H3O.